morning. Today we'll move to another topic named as inversions of double slider crank chain. So before I go for this topic, let me summarize or recall what we have covered in the last lecture, and then I will move to this topic. In the last lecture, we discussed about inversions of single slider crank chain. That means you have taken one kinematic chain where the links are 4 in number. Out of these 4 links, one of the link is slider. And we have seen the pairs, 3 turning pairs and 1 sliding pair. With fixation of different links, like 1, 2, 3, 4, we got a different mechanisms named as like IC engine, first inversion, and second is Whitworth quick return motion mechanism, and third one slotted lever mechanism, and the fourth one is hand pump. So that is the previous lecture what we have discussed. Let us simply in quick glance we can go for those things what we have discussed in 2-3 minutes. Then I will move to the today's topic. The first inversion which we have discussed is the reciprocating engine and compressor. That is, link 1 is fixed and crank is rotated, then the piston, the slider sliding and gives in one case power and one case it gives a compressed air. This is the first inversion which we have seen, that single slider crank chain first inversion. Then we have gone through the second inversion, that is a quick return motion mechanism named as a Whitworth quick return motion mechanism, where forward stroke is completed in more time and return stroke is completed in less time. So that is one example. Then we have also seen in another application of this is a rotary engine, where your entire mechanism, that mission is going to be revolved. So that is another case which we have seen. Rotary engine. Then coming to the next is the third inversion which we have shown you, is slotted lever mechanism, and an application is the shaper. Then oscillating cylinder engine, oscillator engine, this is another inversion. And finally, by fixing the slider, this is a hand pump. These are the 4 inversions which I have seen in the last lecture, that single slider crank chain inversions. Now double slider crank chain. In the earlier case, you have one sliding pair, that is one slider is available. Now there are 2 sliders, then 2 sliding pairs are there. So here, this is the diagram, a double slider crank chain, where I have taken 2 sliders named as A and B. Named as A and B. These 2 sliders are connected by a coupler which is link 3, and we have taken link 1 is fixed. So here, by fixing either this slider or this slider, you get the same mechanism. That is one inversion. Then fixing the link 3, you get another inversion. Then fixing the link 1, you get the final third inversion. So here we get only 3 inversions, not 4 inversions, because both slider A and slider B are identical. So you get the same output by fixing any one of them. So here, the first inversion, let me take a case by fixing the link 1. So you can see here the same demonstrated here, like this is the link 3, this is the link 3, and there are 2 sliders are there. You can see here there are 2 sliders are there. You can see here, this is the link 3. So this is the link 3. This is the link 3. So link 3 is rotating and causing sliders are moving. Sliders are moving. Let us see. This is the link 3, and you can see there are 2 sliders here and here, and those are the sliders here and here, and those sliders are sliding in the slots provided. One is vertical slot, another one is a horizontal slot, and by revolving this 3, these 2 sliders are sliding in these guideways or slots provided here. This is the first inversion. So this inversion is obtained when the link 1 is fixed. When I fix the link 1, that is the link 1, I get this inversion. So the 2 adjacent pairs, like 2, 3 and 3, 4 are turning pairs, and the other 2 pairs 1, 2 and 4, 1 are sliding pairs. So you can see here 1, 4 is a sliding pair, and like here the another one is 1, 2, 1, 2, 1, 4. 1, 2, 1, 4 are sliding pairs. Then the other 2 pairs, that is 2, 3 and 3, 4 are turning pairs. So in this mechanism you have totally 4 pairs. Out of them 2 are sliding pairs and 2 are turning pairs. 2, 3, 3, 4 turning pairs, 1, 2, 4, 1 are sliding pairs. Okay. So this is the first inversion of a double slider crank chain by fixing the link 1. Okay. So what output we get by this mechanism, let us see in the mathematical analysis. So the same animation which I have shown there by fixing and moving the 2 sliders is available here. 2 sliders, slider 1 and slider 2. They are moving in the slots provided. Of course, the animation is given with the help of a gears are connected like that. So you have a gear wheel for this slider and gear wheel for this slider, and they are coupled and given the same motion. In the previous slide, we have shown how simple slides are sliding. Here to simulate with the help of gears, they have shown it. So here what we get the output and what is the objective of this mechanism, let us see by mathematical proof. So here you can see that there is a cross like this which is identical to this. There two sliders are kept, like one is slider A and another one is a slider B, and I have taken the extension of this AB like A, B, C. There are 3 points I have taken. One is A, B, C. So I have called AC, this is P, and I have called BC as a Q. And this AC makes an angle theta with the horizontal. Okay, so I have taken ACP and BCQ. With the simple geometry, okay, we can write what is cos theta and what is sin theta. So I have called this C point as an x coordinate and y coordinate by taking my axis. My axis of this is shown like this. This is my C point, x and y coordinates. Okay. So I can write here, this is x by q. This is, if I take this triangle, so x is q cos theta. You can see here. So if this is theta, then this is also theta. Similar, this y coordinate, this is, so P, this is P sin theta. How we can write? Let us see. Cos theta is equal to cos theta. You can write here cos theta, that is cos theta can be written as your x coordinate. What is your x coordinate? Which is q. Okay, so this is x cos theta. One second. Cos theta is this P, and y coordinate is P sin theta. So x by q is cos theta, and sin theta is y by p. So you can see that is sin theta. Sin theta is this y coordinate by p. In this triangle, say I call ACQ. In ACQ triangle, I can write sin theta is equal to opposite side. What is the opposite side? Y ordinate. By the hypotenuse is P. Sin theta is y by P. Similar cos theta. So cos theta is written as here. This is x coordinate, and what is this? Cos theta is equal to x by q. Then I can rearrange it like this. I can rearrange it like x square is equal to q square cos square theta then y square is p square sine square theta. Then I can rearrange that like x square by q square is cos square theta, say equation number 3. I call this is 1, 2. Then y square by p square is sine square theta. This is equation number 4. So by adding equation number 3 and 4, equation three plus 4, I can write x square by q square plus y square by p square is equal to cos square theta plus sine square. So the left hand sides I have added. So x square by q square plus y square by p square is equal to cos square theta plus sine square theta. We know that cos square theta plus sine square theta is equal to 1. Isn't it? So it gives x square by q square plus y square by p square is equal to 1. That means it is nothing but an equation for an ellipse. This is, recall your mathematics, we write the equation for ellipse is x square by a square plus y square by b square is equal to 1. It's ellipse. Ellipse. That means this traces an ellipse. That is what you can see here. That is what you can see here. So the extension of this link is creating an ellipse. When the sliders are sliding in these blocks, then the path traced by the point C is representing an ellipse. It's representing an ellipse. Suppose in case your P and Q are same, then what it happens, P and Q same, then x square plus y square is equal to some p square. Then it gives a circle. That means if you take a point such a way that the midpoint, if you take this extension link midpoint is at V, then it traces a circle. But circle tracing, no mechanism is required because circle is a one which can be drawn very easily. Okay, that's why this is not used for circle creation. This is used for to create some ellipses. By changing the point of this, we can change the major and minor axis of the ellipse obtained. So this is the first inversion, which is called an elliptical triangle. This name we call it as a elliptical triangle. Elliptical triangle. The first inversion is an elliptical triangle. Let us come to the next inversion. That is the second inversion, okay, which is called a Scotch Oak Mechanism. It is called Scotch Oak Mechanism. How we can get this mechanism and what this mechanism will do. So earlier we said we have fixed the link 1 and we got a elliptical triangle. Now any one of the slide tracks of the first inversion is fixed, then the second inversion, which is double slider crank chain, is obtained. That is a Scotch Oak mechanism. So here the link 4 is fixed. You have taken 2 sliders, fix any one slider which gives one of the mechanism, the second inversion. the link 4 is fixed. Then this, the end B of the crank, rotates about A and the link 1 reciprocates. So this rotates, okay, and then it reciprocates and then it causes sliding motion. So basically this Scotch Oak mechanism is used to convert the rotary motion into sliding motion. The input here is a rotary motion which is converted into sliding motion. Okay, so this is another simple mechanism where a rotary motion is converted to sliding motion. Here what we did is we have fixed the link 4. Then input is given to the link 3 which is rotating and which causing the slider to move like this, and it pushes the entire mechanism. So the rotary motion is converted into reciprocating motion. And finally, the last inversion, the third inversion. Here we don't get 4 inversions because sliders are 2 in number. By fixing any one of the slider will result the same mechanism. That's why we get only 3 inversions. What is the third inversion? Let us see. So this is the third inversion where we fix link number 3. So link number 3 is fixed. So it gives a device called a Oldham coupling. Where we use this coupling and what purpose we use, how this mechanism will work, and how we can simulate our inversion, let us see. So the elaborative view of all the parts are given here, like link 2, link 4, link 1. This link 2, this is the link 4, and this is the link 1. And this is the third link which is fixed. So you can see here, you can clearly observe the axis of the second one is not matching with the axis of fourth one. There is some amount of eccentricity. Is there. There are so many practical cases we see that the input shaft axis is not matches with the output axis. There is some amount of axial misalignment will be there. Not misalignment, it is available in the system itself. We cannot change anything. Only thing is we can have a device which can transmit the motion from the one element to the other element smoothly, so that like here, this is a rotary motion, and input and output also a rotary motion. So I need to transmit the power from here to here, where the input shaft axis is not matching with the output shaft axis, by a intermittent black of 1. You can see here there is a slot on the link 2 and there is a slot on the link 4, and there is a corresponding projections are there on the middle one, that is on the link 1. One is like a projected teeth on one in y direction and projected teeth on x direction, like this. So when this rotates and when this also rotates, whereas the intermittent black so simply slides. So it moves vertically up as well as it moves horizontally. It guides, so which is very quite commonly used mechanism to overcome the offset of 2 shafts to transmit power, okay, and the offset should be a small amount. It's not very big amount. This misalignment, where here we have shown it's not very much large quantity, it is a small amount. So the rotary motion without disturbing anything is transmitted to here, okay, by the intermittent link 1, that is the third inversion, that is Oldham coupling. So these are the 3 inversions we get in this. The first inversion, that is by fixing the link number, by fixing the link number 1, this is elliptical trammel. So by fixing the link 1, the basic mechanism results an elliptical trammel. So that can also be used to obtain a circle, but nobody uses it for a circle because circle can be drawn or circle can be generated very simply, whereas ellipse generation is different. That is why in olden days, not nowadays, to get an elliptical path or elliptical motion in certain practical applications, they used to use this mechanism. Then the second inversion is by fixing the link 4, converting rotary motion into the reciprocating motion. That is a Scotch Oak mechanism. The mechanism name is Scotch Oak mechanism. And finally, this is Oldham coupling, where link 3 is fixed. Link 3 is fixed. That means you have the link 2 and 4 rotation with the intermittent link with 1. So this is the third inversion. So with this, the theory part is over under this unit, and we will confine separately 3 lectures on problem solving. One is on degrees of freedom, and another one is a shaper planar problems, and one more thing is comparison of various mechanisms, and to summarize it. So let us summarize the entire thing in the first unit what we have discussed. Machine, mechanism, links, kinematic pairs and inversions. These are the terms which we have come across very beginning. So a machine consists of mechanisms. All the machines are a part of mechanisms, but mechanisms are never called as a machine. That is what we said very beginning. A machine is a one which consists of number of mechanisms, and it performs an output, a work done, okay, that is called a machine. Then kinematic links and pairs. The links, kinematic links, which are not rigid bodies, but they are resistant bodies. We said a body is and we said to be resistant, or it can behave like a rigid if it serves the purpose of its duty, like a belt, like a fluid, where they are not rigid but they behave like a rigid when they are actually used in the practical application. Then pairs, we have seen kinematic pair, joining two links, okay. We distinguished them like based upon their relative motion, based upon their type of contact, based upon how they are holding. Sliding pair, turning pair, okay, rotary pair, screw pair, based upon the relative motion. And we have also distinguished like lower pair and higher pair. If the area of contact if the contact is area of contact between the two surfaces, we said it is a lower pair. And if it is a point contact or a line contact, we said it is a higher pair. And finally we said inversion. So by fixing the one of the link in a kinematic chain, we get a mechanism. By changing different fixation of the links, we get different inversions. That is what we have discussed in the last 3 lectures. That is a quadric cycle chain, single slider crank chain, double slider crank chain. All are the inversions of that. Then what are the important formulas which we have come across in this chapter is the first one, Kutzbach criteria, Okay, that is n is equal to 3 into L minus 1 minus 2j minus h, where n is nothing but degrees of freedom, L is number of links, and j is the number of joints, that is with a lower pace, and h is with a higher pace. So this is L stands for number of total links, and j stands for lower pace, h stands for higher pace. Okay, and the left hand side shows the degrees of freedom. There is a Kutzbach's criteria which is applicable for planar mechanisms. Okay, suppose in case you don't have a higher pace, that is, then the equation simply will be converted, h becomes 0, n is equal to 3 into L minus 1 minus 2j. So this is also, sometimes we call it as Grubler's criteria, okay, and that is for the degrees of freedom is concerned. Then Grashof criteria, this is another one which we called as S plus L is less than P plus Q. So this is the basic equation. By equating less than and making greater than, we call it as a less than 1, less than P plus Q, that is S plus L is less than P plus Q. We call Grashof's first type of mechanism, and S plus L is equal to P plus Q, and S plus L is greater than P plus Q. So we said this is the class 2 type of mechanism, this is a special mechanism under the Grashof criteria. So we have seen these 3 and its practicality in a, that is a quadric cyclic chain. We have seen all these things. Okay, so with this we can conclude the theory part of the first unit, and we spend 2-3 lectures on problems related to these topics what we have discussed. Mainly one complete lecture I put it on a degrees of freedom, and one lecture on solving the problems in shaper and planar, like the Whitworth peak return motion and crank and slotted lever mechanism problems. Okay, thank you.